Hello everyone, my name is Hussein and I'm working as a data scientist at IDEA. Today I will be speaking about the SKA Data Challenge 1 and how we actually try to turn it from a research challenge to a hackathon project. I have been working on this project with Krishna. He's a postdoc at IDEA, UCT, and Carolina Odman, which is my boss at IDEA. Okay. So what is the SKA Data Challenge? So the SKA itself, they try to build for data challenges with the intention to familiarize the science community with the standard products that the SKA will deliver. They planned for four challenges, two of which has happened already and two are yet to come. Um, we will be focusing on this video about the face data challenge. Um, So the first challenge really has three different objectives, which is the first one. Three different objectives, but they are related, obviously. The first one would be try to do source finding, and then source property characterization, and then source classification. For the source classification, you probably will need to use machine learning with that, or machine learning, yes. And our problem in this case is a multi-classification problem where you will need to classify between two different kinds of AGNs and SFGs, which stands for star-forming galaxies. The data used for this data challenge is simulated data with three different frequencies and three different integration times, where the integration time varies from 8, 100, and 1000 hours. And you can see here from the image as the integration hour increases, the less noisy the image becomes. Now, what is our rollout idea? We basically try to reverse engineer the original code or the original pipeline, and we try to turn it to hackathon format or a tutorial based. And the reason is that we want to help students to get familiarized with the challenges that the SKA will present, also get full perspective of the pipeline from trying to find sources up till using machine learning, and also gain confidence to participate in upcoming challenges. The next data challenge, the third data challenge, I think it will happen somewhere in January. So maybe we should be able to participate in the fourth one. And now I will try to show how the original workflow looks like, and just to give more of a reason why did we try to basically turn it to hackathon. Um, so this is the original workflow, and this is just some text which they tell you that this you can use this command in the terminal to basically download the data. The notebook really from here has 6 cells, and each cell has a very specific objective. So, for instance, here you try to pre-process the images, and the pre-processing you try to do two things, which is primary beam correction and to also to cut or crop the images, so you can separate the training images from the testing. And in the second step here, we try to do source finding. In the code, they try to use PyDSF. And the third step here is we actually use machine learning to do multi-classification problem. And here you can see that they actually try to illustrate this using random forest. And so on. This is the fourth cell, the fifth, and the sixth. I will just, yeah, if you can see here, the workflow itself does not have a lot of explanation. It's just very straight to the point, and it lacks a lot of images. Like I said, explanation again. That's why we actually try to turn this into a tutorial. Now, here the tutorial. We have a GitHub link, but the GitHub link will just like the file itself. The size of the file is very big. That's why I would be trying to explain it from here. I mean, I won't be able to open it from Git. So this is original. The pipe that here has a th file, which basically uh, it shows just to download the data. And this is the data. So, for instance, if we try to follow this, these are the fits files, and it will be downloaded on the data and sample images. And this is where you actually find here sample images. And if you open it, you can find the fits files. Now, if we go back, so this is just the requirement file, which we use to actually create this virtual environment. So we will be able to run the notebooks here. So the notebooks, we just have two notebooks. One is really more about the pre-processing and how would you deal with radio astronomy data. And the second tutorial would be more about machine learning. In the first tutorial, we will cover topics like image clipping, primary beam correction, and then how would you split the data from training and testing into training and testing, and then source finding using PyDSF. The PyDSF will really give you like a data frame, which will be used in the second tutorial. So we will try to explore the data frame, and then we try to pre-process the data so we actually can remove some of the unnecessary features. And then we try to use machine learning model to train on the data frame file, and then we try to test the machine learning model. Just to open the first tutorial. So yeah, compared to the original pipeline, you can see there's like a big difference. So in instance here, we try to explain the primary beam correction, and then we try here to explain source finding. Obviously, all thanks to Krishna, because every word here has been revised or rewritten or added. So he added a lot of information here. And also, if we go a little bit down here, we try to show a histogram of one of the images. We try to focus on the 1.400, I think is in megahertz. Let me check again. Yeah, gigahertz, 1.4 gigahertz. And then here we try to show the image clip is sigma, the image clipping. And here we try to show the image before and after the clipping. And you can see here, we can see here more resources because we removed some of the outliers. For the pre-processing, we try to do primary beam correction and then we cropped the image. For the pre-processing, we actually try to show how the image looks like before and after primary beam. If you focused enough, you can see the image does alternate between two images basically, which is before and after the primary beam correction. And then yeah, we do source finding, and we do source finding, and the source finding, it does give us a data frame. And this data frame is basically what leads us to the second tutorial. For the second tutorial, here's the data frame itself. It has about 7,000 rows and 46 columns. Not all the 46 columns are suited to be used to train a machine learning model. So we try to do some pre-processing. And here we can see from 47, we try to reduce this to 35. Is it what? Yeah, sorry, from 36 features, we try to reduce it to 35. And this is all the frequencies between the three classes, which is the two different AGNs and SFGs. Yeah, so this is pretty much about it. I just want to show you guys how this is different, why we did it. If you do have any questions, you are welcome to ask us at any time. Yeah, thank you very much, and see you in the next video.